De-icing chemicals can have serious effects on the environment near a roadway. Not all environments are the same, and determining where the most sensitive areas are can help you maintain a safe roadway while protecting the most sensitive areas. This video illustrates how to set up and use a sophisticated software tool that can analyze environmental conditions and highlight the roadway's segments where de-icing chemicals can have the greatest effect on the local ecosystem. Before installing the tool, there are several prerequisites for use. Esri ArcGIS Pro version 2.9 must be installed on the workstation. Esri Spatial Analyst or 3D Analyst must also be installed for data processing. You will also have to provide a plow route network line file representing where de-icing chemicals may be applied. For example, all the county roads in your county, or it could be an Esri shapefile representing specific plowing routes. Once you have these elements, there are several other data sources needed for analysis. These can be downloaded from public sources. Mandatory data elements are the USDA Natural Resource Conservation Service NRCS Soils Polygon, the U.S. Fish and Wildlife Service National Wetlands Inventory NWI polygons, and the National Hydrological Dataset Streams and Rivers NHD line file. First, we need to install the Esri ArcGIS Pro add-in. Please note, full IT administrator privileges are required to install. Also, at this time, the user should have the provided installation guide PDF as additional reference. Download the de-icing tool.zip file to your computer. Unzip the file, and it will create a de-icing DS tool folder. Open the folder and run the install.bat file. The installation wizard for ArcGIS will run. Click on the Installation Configuration button and allow the process to run. When finished, an Installation Succeeded message will appear. Once the tool is installed, you'll see a de-icing decision support menu in ArcGIS Pro. At this time, the user should also have the de-icing decision support tool help and quick start guide PDF for reference. Selecting that menu will display the icons to operate the tool. These should be used in a left to right sequence, starting with the environment settings. There are two items that should be configured for your environment: the input workspace, which is where your data will be kept, and the input coordinate system. The input workspace can be a geodatabase or a directory. The coordinate system will typically be the UTM zone for your state. Once the environment is configured, click the Input Data button to load the datasets needed for analysis. On the right side of the screen, a parameters list will appear to select the datasets. The start items are mandatory. Other elements can be loaded if they're relevant to your analysis area. There are tool tips available to help you locate and download the datasets. The next step is activated by clicking the Buffer Processing button. In the panel on the right, input your plow routes line and set buffer distance. The buffer distance tells the tool how far away from the plow route to analyze conditions. Generally, 10 to 15 meters is a sufficient buffer, but if airborne salt that affects nearby vegetation is a major concern, a buffer of 30 meters can be used. Now you can click Run in the lower right corner of the screen. This will clip the data so that only the area specified by the buffer will be analyzed. If you're working on a statewide level, this step might take 45 minutes to complete. The output from this step will be written to the location you defined in Step 1 as your input workspace. Now that the data preparation is complete, we can run the weighted overlay analysis functions. This is where de-icing sensitivity is calculated, and you can adjust how the model emphasizes different environmental features. Click the Weighted Overlay Analysis button and drag and drop your input layers from the Contents pane on the left to the Weighted Overlay Inputs pane on the right. Now you can adjust how much each of the inputs affects the sensitivity analysis. Each layer is assigned a value that can range from 0 to 100. Note that these are percentages, and the total of all the layers must add up to 100. In cases where the layers have multiple features, you can specify how much each influences the model outputs by assigning a rating from 1, very low, to 9, very high. Once your model weighting is complete, save it by clicking the Save button and typing in a name. Then click Run. The output of the model will be loaded into your Contents pane on the left. Finally, you can produce a vector or line representation of the data. The vector representation is color-coded based on the model outputs. This can be very useful for importing sensitivity analysis data into other GIS systems for mapping and planning purposes. To create the roadway coverage, click the Raster to Polyline button. Tick the checkbox next to your raster model output in the Contents pane. In the Tool pane on the right, input the name of the raster into the Input Weighted Overlay result box. Input the file or other data source containing the plow routes. Give your output a name. Click Run. When the process is finished, the results will be automatically entered into your Contents pane. The model output can be color-coded using a layer file containing high, medium, and low classes. The layer file was included in the zip file with the tool software. To use this layer file, click on your output line file and navigate to the Symbology pane in the top right corner. Click on the 3 parallel lines and select Import Symbology. From there, your input layer will be your output line file and should fill in automatically. Add the layer file from the zip file by navigating to the location of the unzipped folder via the browser function. Ensure the source field and target field have populated a value. In this case, it will be named Impact. From there, click Run and your symbology should be updated to green, yellow, and red lines. You now have a customized analysis showing the areas that are environmentally sensitive to de-icing chemicals. This data can be used to plan alternative de-icing approaches, such as pre-treating with brine or using treated salts, or used to identify strategic reductions in de-icing applications. The tool has the flexibility to consider many different environmental inputs and allows you to perform the analysis multiple times to assess sensitivity to different weightings that you can select. With this tool, you are now ready to analyze and optimize your plow network for use of de-icing chemicals.